Okay, this is the second part of my comments on question 64, part 4. This is the same very complex set, but this time I would like to argue that this set is closed. Okay. Now, the method which I chose is by definition, and by definition we know that the set is closed if and only if when you take a complement and the complement is open, and that's what we would like to address, why the complement is open of that set. In order to do that, first I would like to carefully describe what it means that the point is in a complement. Alright, so let's just take a point, x, boldface, with components x, y, and let me carefully explain what it means that this point lands in a complement. And that will be three options actually for that point. It's either such point that the mod x is bigger than 1. That's one option for this, like for this point to be in a complement. Or mod x between 0 and 1, strict, non-strict, but y fails to be sine 1 on x. And the third option is when x is 0 and y in absolute value bigger than 1. Okay? These three options, they cover all possibilities for a point x to be not in S, so to be in a complement. Okay? The moment we realize that, I would like to present for the complement alternative description. And that will be the hardest part of the entire solution. I mean, it will be the hardest part for you to actually comprehend. Look at this. I suggest the following description for the complement of S. Alright? Look at this. It's a relatively long description, but it's a complete description. My complement can be described like this. It's a union of three big sets. One of them is like that, and that covers all of these possibilities. One of them is like that, and that covers all of these possibilities. It's a larger than this condition because I didn't include x equals 0 in here, but that covers all of these possibilities. And these unions, we don't aim to make these unions disjoint. The middle section is the hardest one. Because the middle section here, I look at the infinite union across positive epsilons. And each individual set is like that. X in modulus in absolute value bigger than epsilon, and y doesn't equal 1 on x. The reason for this will be seen in a few seconds actually. The reason for this complex construction. Now, in order to conclude that the complement is open, because I can reference the result that union of open sets is an open set, and this is true even for infinite unions, what I will do now, I will argue that this set is open, this set individually is open, and this set individually is open. And that's a very easy argument actually, because now I can use the pre-image result. For instance, for this set, if I take this function, then the first component here will be pre-image of an open set in one dimension under this continuous function. Hence, it is open. For this function, again, if I choose this function f3, for this set, if I choose function f3 like this, then the set in R2, everything is happening in R2 now, will be a pre-image of an open set in R1. Which open set? This open set. Negative infinity 1, union 1 plus infinity, even though it actually is not, it's negative infinity minus 1. This is a set which is needed here and here. So once again, in order to conclude that this set and this set is open, all I need to reference is pre-image result and just mention this continuous function, hence since it's elementary, and this open set. And this one will be pre-image of this open set under this continuous map. Same story about this component. It's a pre-image of this open set under this continuous function. The middle section is slightly harder, but it's still a pre-image. That's the function which I have to choose. This is a function which I have to choose. The harder part here is that I don't consider this function everywhere, because if I consider it everywhere, I'll have problems with continuity because of division by x. But if I only consider this function on this open set, then I no longer have any problems with division by 0. And hence, this again will be open set because it's a preimage and the continuous map of an open set. And union of these individual open sets is open set as well. And that's the only way, actually, I think, the only logic, complete and formal way to conclude that S complement is open and hence S itself is closed. Thank you very much. I'm finished.